Welcome to this simulation of an FPV combat drone using Arduino. In this demonstration, we'll explore how the basic controls of a drone can be implemented using an Arduino Uno, LEDs, potentiometers, and an MPU6050 sensor. Let's start by introducing the components we'll be using. At the heart of this project is the Arduino Uno, which serves as the main controller for our simulation. We have 4 LEDs that will represent the motor outputs, allowing us to visualize the speed of the drone's motors. These LEDs are connected to PWM pins on the Arduino, specifically D3, D5, D6, and D9. Next, we have 2 potentiometers, which will act as our joystick inputs. These potentiometers are connected to analog pins A0 and A1 on the Arduino, and they will simulate the drone's directional control. Lastly, we have an MPU6050 sensor, which provides accelerometer and gyroscope data. This sensor will help us simulate the stabilization of the drone. Let's take a closer look at the wiring. The first LED, which represents motor 1, is connected to pin D3 on the Arduino. The second LED, representing motor 2, is connected to pin D5. Similarly, LEDs for motors 3 and 4 are connected to pins D6 and D9, respectively. The potentiometers are wired as follows. The first potentiometer, representing the x-axis of the joystick, is connected to analog pin A0, and the second potentiometer, representing the y-axis, is connected to analog pin A1. The MPU6050 sensor is connected using I2C communication, with the SDA and SCL lines connected to A4 and A5 on the Arduino. Code, the Arduino program reads the analog inputs from the potentiometers to determine the joystick's position. These values are then mapped to control the brightness of the LEDs, simulating the speed of the drone's motors. Additionally, the MPU6050 sensor provides real-time accelerometer and gyroscope data. This data is used to stabilize the simulated motors by adjusting the LED brightness based on the sensor readings. For example, when the joystick is moved forward, the LEDs corresponding to the front motors will brighten, indicating increased speed. Similarly, when the joystick is moved to the left or right, the respective LEDs will adjust to simulate the drone's movement in that direction.